Francis Masi. I'm a student studying telecommunications engineering and electronics at the Malawi Polytechnic. We're doing a project on extraction of heat energy from compost.
I am Gerald Ngurowe, a student at the Polytechnic doing electrical engineering, specializing in telecommunication and electronics. Actually, here we are doing a project on the extraction of heat from the compost.
And my name is Charles Kitsego, a student of Institution of Malawi, University of Malawi, the Polytechnic. I'm doing my third year, doing electrical engineering, major in telecommunication. And here we are, one of the group who we are studying on how we can extract heat from the compost.
We're in Malawi right now, and in a small town close to Blantyre, Lunzu, and the exact place in Lunzu we are Ministry of Agriculture.
Okay. And what are we looking at just over here, over your shoulder?
Over my shoulder there is the bin. We have a bin machine. Inside it is we have a compost, from which we want to see how we can extract heat from it. Sure. So it is fenced for a purpose, and everything there is for a purpose, and you understand that.
Okay. Sure. We work hand in hand with the Wasted department at the Polytechnic. Actually, when it was out in the news, we applied for it. Actually, when we came up with this idea of extracting heat from the compost, and then we got our lucky, we got funding from the MREAP. Yeah, so we are under the REEF, Renewable Energy Entrepreneurship Fund. So that's where we got our grant. Yeah, so they are the ones who fund us to come up with this, to set up this project here.
Okay.
We're trying to prove to farmers that the practice that they usually do, which is composting, they can be able to obtain heat from that system, which actually they don't know. So we're trying to improvise and see if they can be able to maximize that heat, so they can be able to use it maybe in warming water or other purposes.
Shall we go check it out?
Yeah, no problem.
Yeah, sure.
We have maize stalks. Actually, the maize stalks provide us with a carbon, and then we have potato peels, and then we have manure. These manures, you can say the chicken drops. These provide us with a protein. Actually, in the protein we know there is a nitrogen, so the two compensate to each other. So we try to maintain the carbon to nitrogen ratio to 40 to 2. That is the nitrogen 40, carbon 2. And then actually when the ballast is out, we try to bring in actually when there is a lot of nitrogen, we try to bring in sawdust, so they maintain the carbon to nitrogen ratio. And then in terms of the water content, as you see at the top, there is an opening. When the materials are dead up, there is low water content. We try to put some water inside. There is this the mixing device, which it's like a stirring device. Actually, when the materials are put inside, they are just left, but as time goes, it's like the materials down there, there are ones that are in action. On the top, they are not in action. So we try to mix up using this device. Actually, it's like a spoke. It's like spoke-like. It has some protrusion. So when you try to to say it, there is the material that is spread up in all directions. So there is a complete mixing of the materials.
Right, can you guys show us how it's actually fed, and show us how it works?
Yep.
All right.
As you do it?
Can open it for me.
Yeah, so these are the maize stalks, a mixture of maize stalks. Yeah, and then this is a Glycidia. It's a leaf from a tree. It has a good quantity of carbon. So it's like moisture is one of the conditions of composition to be more effective. So that's why we add in the water. When it's dry, the microorganisms cannot come in and feeding. They need water to feed.
So after you fed it with this, you put in water?
You put in water. Yeah.
What's the next step?
The next step, maybe we put another layer, and then we put in water. Maybe we put another layer, and then we put in water. Maybe to a certain level somewhere here.
Okay.
So it's like we fill water, fill water, fill
What's
water.
this?
This one.
Yeah.
This is used for stirring. It's more of like, it has a shaft inside, and it's more of like sponge, like fingerlings. Yeah. So when you stir inside here, there it also mixes the things
The
together.
materials are mixed so that heat should not be concentrated on one place and less on the other place, but it should be a constant distribution of heat. Sure.
So what's under here?
Okay, bottom here is mesh, which is used to allow the air to circulate inside the bin machine. Actually, it also supports the material. It's a metal. It's a bit strong that it can also hold the materials down there. So basically, it's used for aeration. So apart from the stirring device that we have, we also have the mesh down here to allow air to go inside the machine.
We have an opening here which is used for extracting out the decomposed materials.
Yeah. So these are the materials. So actually, there's a mixture of cow dung. There's a mixture of cow dung. There's a mixture of maize stalks. A mixture of the leaves. So when these materials, when they decompose, it will form manure. So that manure can be used in their farms.
Yeah.
All right. Here I want to check the temperatures so far. What the temperatures are inside here. So since we have our thermometers somewhere this height, we use the same opening which we use in putting materials to take the thermometers. And this is our minimum and maximum thermometer, which is currently reading up to, for what? Something like 42 degrees currently. This is our maximum and minimum. It will show us the maximum temperature which we have so far reached. But we also have another thermometer which tells us the current reading at that moment. And this thermometer is inside. Yes, and the current is showing us okay, it's going down. It was 42 degrees Celsius. Basically, they want to have about 70 degrees Celsius. And all these experiments, what we are doing, we are trying to get that maximum temperature, that 70 degrees. Sure.
Okay, so you have the compost in there. It's producing heat.
Yeah.
How hot does it need to be for the types of applications you're looking for? What types of applications are you looking for?
Okay, our main target was for us to put in about 70 degrees, right?
Yeah.
70 degrees Celsius.
Yeah.
But then maybe due to some conditions, or we can say maybe because of the volume, maybe it's too small. But then we're able to obtain 51 degrees. But honestly saying, 51 degrees, I think is a bit, it's okay to warm up water for someone to bath. Yeah, so I think the 51 degrees can be able to warm water for bathing. Yeah. It can also be used in greenhouses if you have such a machine, which will be able to produce heat into the greenhouse.
Mhm.
Yeah. So instead of having like heaters which are electronic, they'll be able to use electricity. So instead of using that, you can actually just use this machine, and will be able to. Yeah, you can actually even feel the heat here.
How did you get this thing actually built, and where did you get the materials for it?
We actually collect these materials from the surrounding areas, like the markets, because people just throw things away. So as we're able to collect those things with the help of some people, so they collect those things and then we'll be able to bring them here and put them here. So it's mainly, I can say, it's things which people call waste.
Yeah.
But then we use that waste which they throw away and use it to obtain this heat.
So here in the city, or here in the town, but not out in the countryside,
Yeah.
you've got waste as well.
Yeah.
Yeah.
That's available.
Yeah.
Yeah.
What's happening to that right now?
Okay. Oh.
Okay, actually, all the garbage they're just thrown, they're just left to decompose without nothing be done to it. So we thought it wise, and as actually we are expecting it, it's like also helping to clear out the environment. So it's like also cleaning the environment.
Like we have one in Brantford, it's a landfill. Yeah. So like in the main cities there, when the people have their garbage and everything in their bins, those cars, they come, they collect those bins and in their cars, then they throw that garbage into the landfills, which makes it more compact. So that's what he was saying, that it's a bit slower that side because there's no aeration of there's no good mixing. Yeah, so it's actually harmful to the environment.
Yeah.
It's like killing 2 birds with 1 stone.
2 birds with 1 stone. Nice.
3.
3 birds.
With 1
Tell
stone.
me the birds. What are the birds?
One bird is you are having the heat there.
Yeah.
The second bird is you having manure. The other one is that you are cleaning the
Cleaning
land.
the environment.
Yeah.
Sure. That's nice. Yeah.
Okay, we would like to put that at the next stage after this one, because this was just to prove, like, for more of a, like, research.
Yeah.
So that we are now certain and convinced that there's actually heat produced in here, and at a temperature of 51 degrees, and we know that temperature can be used to warm water. That's what we are now planning to do for a geyser, which maybe will require maybe an extra funding or so.
Sure.
Or
Yeah.
yeah, you can say.
If REEF wasn't there, would you have been able to take this concept this far?
No.
This is an added
I
advantage.
think
to
advantage
improve
is yeah.
the knowledge we had, that it was just a theoretical and too practical. That fund has helped us
to
into
achieve this.
coming up into something, a great, a tangible idea.
Okay.